So for today, I want us to talk about sequences and series. So let's look at question 2.1. It says 7xy negative 11 is an arithmetic sequence. So we know the sequence goes all the way to infinity, like that. So the question says, determine the values of x and y. So let's go to the whiteboard. So what do we know about an arithmetic sequence? We know that it has a constant difference between the consecutive terms. So meaning if I have 7xy, negative 11, and this goes all the way to infinity. This means if I take term number 2, I say minus term number 1. This is equal to term number 3 minus term number 2. But since I have 4 terms, it's also the same as if I say term number 4 minus term number 3. This is equal to term number 3 minus term number 2, like that. So let's go. Term number 2 is going to be x, and term number 1 is 7. Term number 3 is y, and term number 2 is x, like that. Now here, term 4 is negative 11. You say minus y, and this is equal to y minus x. So let's go to the first part and let's solve for y, or rather, let's make y the subject. So if we make y the subject, we take negative x to the left, it becomes positive. So then we have negative 2x minus 7. And this forms the first equation. So we come to this one. We don't really want to solve for y here. No, we don't. But let's just write it a little bit nicer. So we take this negative y to the right. It becomes positive. And then we take the negative x to the left. It becomes positive as well. So we have x minus 11 there. And let's call this one the second equation. Now from this point, we substitute the first equation into the second. So this means every time I see y, I actually see 2x minus 7. And this is set equal to x minus 11, like that. Then from here, I distribute the 2. So 2 times 2x, we get 4x. And 2 times negative 7 is a negative 14. And this is equal to x minus 11. Then from here, I take this x to the left and negative 14 to the right. So x becomes negative. 4x minus x is 3x. Now this negative 14 becomes positive when it gets to the right. So negative 11 plus 14 is a positive 3. Then from this point, you'll just tell them, this means the value of x is positive 1. Of course, after dividing both sides by 3. So now that we have the value of x, we go to the first equation and substitute the value of x in order to find the value of y. So 2 minus 7 will just be a negative 5. So we have the value of x and the value of y. And so we are set. So this is the first way you could have done it. Or you could have said, if I have an arithmetic sequence, what is my general term? That's the second way you could have done it. Because firstly, you did it simultaneously. It's a little bit long. So you'll tell them that the nth term is equal to a plus n minus 1 times your constant difference. So let's say our last term, which is the general term, is going to be negative 11 in this case. And a we know is the first term. So the first term is going to be 7. Now this negative 11 is at position number 4. So we don't know what is the value of the constant difference. So simplifying here, we get negative 11, which is equal to 7 plus 3D, like that. So taking this 7 to the left, it becomes negative. So negative 11 minus 7 is a negative 18. So this means the constant difference will just be negative 6, like that. 6, 12, 18, yes. So now that we have the value of the constant difference, what are we going to say? Then we come back and say, let's find the value of the constant difference literally. How so? Because we know that the constant difference is actually term number 2 minus term number 1. So the value of this constant difference is negative 6, but term number 2 is x, and then you say minus 7. Then from here, you take the negative 7 to the left, it becomes positive. So this means your x is a positive 1. Then you come back again and say the constant difference, I can have it as term number 3 minus term number 2, like that. But the value is going to be negative 6, and term number 3 is y, but term number 2, we just found its value, it's positive 1. So taking this negative 1 to the left, it becomes positive. So negative 6 plus 1 will just be a negative 5. Yes, so I don't think this one is a little bit too long. No, it's perfectly fine. So if you don't want to do this, then you are welcome to solve simultaneously, as we did in the first place. But this is how you find the value of x and y if we tell you this is an arithmetic sequence. Okay. Now, what about the second question? What does it say? So let's see. This is 2.2. It says, given this quadratic number pattern, negative 3, 6, 27, 60, it goes all the way to infinity. So firstly, we want you to determine the general term of this pattern, after which we need you to calculate the 50th term of that quadratic pattern. And then show that the sum of the first number of first differences of this pattern is given by this. So let's do the first 3 questions, then we shall focus on the last question. Yes, we shall focus on the last question. So this is the pattern. They say we have negative 3, 6, 27, 60. And this goes all the way to infinity. So in order for us to determine the general term, we understand that a quadratic pattern has a second constant difference. So if you say 6 minus negative 3, you get 9, and then 27 minus 6, you are just going to get 21, and then 60 minus 27 will give you 33, like that. Then from this point, you say 21 minus 9 will just give you 12, and 33 minus 21 also gives you 12, like that. We know it as a second constant difference. Now, what are you going to say? You know that the first term of the second constant difference is actually equal to 2a. And then this one, the first term of the first difference is 9, is equal to 3a plus b. Now, the first term of the quadratic pattern itself, it's equal to a plus b plus c. So we come back and say 2a equals 12, like that. So meaning the value of a is equal to 6. Then we come back and say 3a plus b is equal to the first term of the first differences. But we know that the value of a is 6. We are looking for b, like that. So 3 times 6 is 18. And then taking it to the right, it becomes negative. So 9 minus 18 will just give us -9. Then from here we say A plus B plus C must give us -3, like that. So from this point, you know your A is 6, and then your B is -9. You are looking for C, but the whole thing equals -3. So 6 minus 9 will just give you -3, and then you have your C. This is equal to that. Now, taking this -3 to the right, it becomes positive, and -3 plus 3 will just give you 0, like that. So we now know the value of A, B, and C, but we know that the general term of a quadratic pattern is given by Tn equals an squared plus Bn plus C, like that. So here we understand the value of A is that, and then the value of B is just going to be that. The value of C is going to be 0, but unfortunately there is no need to write that 0. So this is our general term for this quadratic number pattern. Now from here we need to determine the value of term number 50. So we are looking for the value of the term that is at position number 50. That's how we interpret the situation. So we just substitute 50 every time we see n, like that. So let's see how much we get. So we are just going to get 14,550. So that's the value of term number 50. Awesome. Now the third question, it says, show that the sum of the first number of first differences is given by that equation. So one thing we know is that the first differences forms a linear pattern, or rather an arithmetic sequence. So if we must find the sum of these number of terms, we are actually finding the sum of the first number of terms of an arithmetic sequence. And for that, we can use this equation, or rather this formula. Yeah, let's say formula instead of equation. So this is the formula we are going to use. How many terms are we summing? We are summing a number of them. But here we understand that the first term is 9. How many terms are we summing? It's a number of them. And then what is the constant difference? The constant difference is just going to be 12, because the second constant difference of a quadratic pattern is actually the constant difference of the first difference, which is the linear pattern. How awesome is that? So you have n over 2. So 2 times 9, you'll get 18. Then from here, you distribute. You say 12 times n, and then 12 times -1. So this is what you get, like that. Then you come back and say, okay, from this point, what is going to happen? I'll just have my n over 2, and then I collect the like terms in brackets. So 18 minus 12, how much does it give us? I think it gives us 6. Yes, positive 6, like that. Then after getting this, ours is to distribute the n over 2. So n over 2 multiplied by 12 will just give us 6n squared. And then n over 2 multiplied by 6 will give us positive 3n, like that. And this is actually the sum of the first number of terms of the first differences, like that. And then you are set for this one. So let's look at the ultimate question. 4 marks, the last one. Yes, it's the ultimate question. So this is what it says. It says, how many consecutive first differences were added to the first term of the quadratic number pattern to obtain a term in the quadratic number pattern that has a value of 21,060, like that. So the first thing we need to do here is to determine the position of a term in the quadratic number pattern that has a value of 21,060. That's the first thing we must do. We must determine the position of that term. So let's do that. So how do we determine the position of that term? This is how we do it. So we are going to treat that term as the general term. So in short, as the last term of this pattern. So the general term will just be 21,060, and this is equal to 6n squared minus 9n, like that. Then from here, we write it in standard form. So it's going to be 6n squared minus 9n. We take 21,000 to the right, it becomes negative. So we say minus 21,060, and this is equal to 0, like that. So we realize that we do have a common factor in this case. It's just going to be 3. So if we take 3 out, here we are left with 2n squared, and then it's minus 3n. Now, what about the last part? Let's see. 21,060 divided by 3. So it's just going to give us negative 7,020, like that. Then from here, we divide throughout by 3 so that we are left with this part, like that. Now from here, we can resort to using a quadratic formula. So it says n equals minus b, and then you say plus or minus b squared minus 4ac. This is your quadratic formula. Now the whole thing is divided by 2a, like that. So now we substitute. So we know the value of b is going to be negative 3. And then we say plus or minus the square root of what? B is negative 3, so we square it. Then we say minus 4. A is going to be 2. And then C is going to be negative 7,020, like that. Now this whole thing is divided by 2. And then our A, we said it's going to be 2, like that. Fine stuff. Now from this point, you can decide to simplify your quadratic formula. In fact, that's what you must do. You need to simplify this so you have positive 3. You need to simplify what is inside the square root there. You simplify it to one number, and then you multiply 2 by 2, you get that. So I'm not going to do that, but instead I'm going to go straight and find the value of n. So we said b is negative 3 plus or minus negative 3 squared minus 4 times 2 minus 720, like that. Yes, and then we say in fact, divided by 4. So the first solution, we find that n equals 60. Let's look at the second solution. So here we find that n is equal to negative 117 over 2, which cannot be. So this means the correct value is going to be 60. We can't have a position of a term that is negative, and we also can't have it as a fraction. So n is an element of whole numbers as well as natural numbers. Yeah, let's say natural numbers. Yeah, because a natural number is a counting number. 1, 2, 3, 10, 60, what? We don't have a fraction as a natural number. So we found the position of this term in the quadratic number pattern. But the question didn't say find the position of a term in the quadratic pattern. No, it didn't say that. They said how many consecutive first differences must be added to the first term of the quadratic number pattern to obtain a term in the quadratic pattern that has a value of 21,060. So I want you to observe something that's very interesting. What is that? If you take the first term in the quadratic pattern, you add it to the first term of the first differences. You get the second term in the linear, in fact, in the quadratic pattern, sorry. So what did I say? You take the first term of the quadratic pattern, you add it to the first term of the first differences, you get the second term, sorry. Yes, you get the second term in the quadratic number pattern. Now let's come back. You take the first term of the quadratic pattern, you add it to two terms of the first differences. You're going to get the third term in the quadratic number pattern. You come back again, you take the first term of the quadratic pattern, you add it to three terms of the first differences. So you're going to get the fourth term in the quadratic pattern. Do you see the sequence here, or rather the pattern? So if you add it to one term of the first differences, you get the second term in the quadratic pattern. But if you add it to two terms of the first differences, you are going to get the third term of this quadratic pattern. And if you come back and add it to three terms of the first differences, you are going to get the fourth term of the quadratic pattern itself. So what is the meaning? It means if you take the first term and then you add it to 59 terms of the first differences, you are going to get the term that is at position number 60 in this quadratic number pattern. So to answer the question, we need to add 59 terms. Yes, we need to add 59 terms of the first differences to the first term of the quadratic pattern to obtain a term in the quadratic pattern that has a value of 21,060. So that's the relationship we just investigated. Yes, if you add 1, you get the second term. If you add 2, you get the third term. If you add 3, you get the fourth term. So meaning if you add 59 terms to the first term, you are going to get the 60th term in the quadratic number pattern. Yes, I hope that is clear enough. I hope I explained it. I don't know. How did I explain it? Now you'll just tell me in the comment section if you still need me to explain it again. Yes, but I hope it makes sense now, or at least it makes a little bit of sense. Okay, that's fine. So from here, I want us to focus on the following question, which is question number 3. And this paper was actually written by me in 2020 November. So it holds a very special place in the organ that pumps my blood. Not bad. So let's see question number 3. It's a very nice paper. I think that's why I got so, hey, no, let's not say that. Let's not say that. But let's look at question number 3. So 3.1 says, prove that this series is a convergent geometric series. So that's what we need to do. So what are the conditions for a series to converge? Then we know that the constant ratio must be less than 1, but greater than -1. That's what we know. So it means we need to determine the constant ratio. But this is the series we are giving. The sum of the terms of this sequence from k equals 1 to k equals infinity. So this is what we are given. It's 4 times 3 raised to the 2 minus k, like that. So here we need to determine the constant ratio. But the first thing we must do is generate the first 3 terms, right? So how do we generate the first 3 terms? We need to substitute k equals 1, k equals 2, and k equals 3, like that, so that we get the first 3 terms. Fine stuff. But now here we understand the series goes all the way to infinity, like that. Fine stuff. So if we press everything into the calculator, we are just going to get 12 for the first term. And then for the second term, we are just going to get 4. And for the third term, we get 4/3, like that. And this goes all the way to infinity. So now that we have the first 3 terms, we want to calculate the constant ratio. So we say term number 2 divided by term number 1. I think we should write it like this first. So we tell them that term number 2 divided by term number 1 is equal to 4/12, which is 1/3 if we simplify it. Then we come back and say term number 3 divided by term number 2, it's just going to be 4/3 divided by 4, like that, which is just going to give us 1/3. So here we can see that term number 2 divided by term number 1 is equal to term number 3 divided by term number 2. So what is the meaning of this? It means this sequence is going to have a constant ratio, but the value of the constant ratio between the consecutive terms is just equal to 1/3, like that. And if we give it a look, we can see that 1/3 is less than 1, but greater than -1. So what is the conclusion? We can conclude that the series is convergent, because this is the only thing we need in order to convince the examiner that the series is convergent. So we know that our R is less than 1, but greater than -1, like that. So we are happy for this one. This is how we prove convergence. Fine stuff. Now let's see the second question. This is what it says. It says, if we tell you that the sum from k equals p all the way to k equals infinity, the sum of 4 times 3 to the 2 minus k, if we tell you that this sum is equal to 2/9, the question says, determine the value of p. That's what the question says. So what are we given in this case? This 2/9 is just the sum to infinity of this geometric sequence. And we know that we can only calculate the sum to infinity for a sequence that is convergent, or rather for a geometric sequence that is convergent. That's the only time we can find the sum to infinity. So in this case, we are given the sum to infinity because of this infinity. If it was a whole number there, or rather a defined number, then it wouldn't be the sum to infinity. It would be the normal sum. Fine. But now we understand that every time we see the sum to infinity, this is what we see. It's equal to A divided by 1 minus R. This is the formula for the sum. So the question says, determine the value of P. So in this case, one thing we understand is that we are given the sum to infinity, and we are also given the constant ratio. No, we are not given the constant ratio. We had to calculate it. So meaning the only thing we are left with is the value of A. And quite honestly, in order for you to calculate P, what must you do? You need to generate the first three terms, right? Because then you'll have to substitute your P into this general term. But unfortunately for this one, you cannot generate the first three terms because here we have P. It's not like we have K equals 1, whereby you can substitute 1, 2, 3, as we did previously. So for this one, you can only substitute P, unfortunately. But now that P, when you substitute it, you are going to get the first term. So meaning the first term is equal to 4 times 3 to the 2 minus P. This is the value of the first term. So it means we are going to be able to determine the value of P from the value of the first term. So now that we understand A is the first term, instead of writing it as A, we are just going to say 4 times 3 to the 2 minus P. Because that's what we need for the sum to infinity. We only need the first term and the constant ratio. So if we are given the sum to infinity and the constant ratio, then it means we must find the value of A. So we found the value of A in this case, but we know that A is going to be in terms of P. P, which is a variable, which we must find its value. So it's nice. Fine stuff. So let's work. We'll still have 2 over 9 on the left. And even here, you'll still have 4 times 3 to the 2 minus P. But now we simplify the denominator. So 3 over 3, which is 1, minus 1 over 3. It's going to give us 2 over 3. So because we want to destroy this fraction, so we multiply both sides by 2 over 3, like that. So if we do, this one and that one will cancel out, like that. So when they cancel out, you are just going to be left with 4 times 3 raised to the 2 minus P, like that. But now here you are just going to have what? 2 times 2 is 4, and then 3 times 9 is going to be 27, like that. Then from this point, we need to get rid of this 4. So how do you get rid of this 4? You divide both sides by 4. And of course, dividing both sides by 4 is the same as multiplying both sides by 1 over 4. So that 1 over 4 and 4, they cancel out. You are left with 3 to the 2 minus P. And then at this point, the 4 as well as the 1 over 4, they will simply cancel out. So when they cancel out, what are you left with? It's just going to be 1 over 27, like that. But now you realize that P is in the exponent. So meaning this is an exponential equation. So in order for you to solve an exponential equation, you need to make sure that the bases are the same. So that if the bases are the same, you equate the exponents. Now, the first thing you're going to do, you write 1 over 27 as 27 raised to the negative 1. And this is equal to this thing. Fine. But now you also understand that every time you see 27, you just see 3 cubed. So you have 3 cubed, which is raised to the negative 1. And this is equal to 3 raised to the 2 minus p, like that. Now multiplying your exponents, you find that it's going to be 3 to the negative 3, like that. So it's 3 to the negative 3, which is equal to 3 to the 2 minus p, like that. So now your bases are the same. You simply equate the exponents, like that. So if you must solve for p, you take this one to the left, it becomes positive. Then you take this one to the right, it becomes positive. So this means the value of p is just going to be positive 5. Fine, positive 5. And then you are set for this one. So the interpretation was very important. This is the sum to infinity. And for any sum to infinity, we need to know the first term and the constant difference. But if we are given the sum to infinity and we have the constant ratio, not the constant difference, the constant ratio. So if you are given that, then you must find your first term. So in this case, your first term was given in terms of p, and then it's now easier to solve for p. Yes, it's now easier to solve for p, and then you are set. So if you really enjoyed this video, please don't forget to subscribe, and please like this video as well. And thank you so much for watching. Let's see you in the next video.